everyone, Sebastian here. Just want to introduce this video. It is Bluebook Test 1 Math Module 2B, the harder section. I've already done all these questions as solo videos that you might have seen, but now you can see them all in one compilation if you want to, grind through them all. So I hope you enjoy, and if you have any questions, let me know. Which expression is equivalent to 9x squared plus 7x squared plus 9x? Okay, and this is just testing combining like terms, and there's no FOILing, there's no multiplication, so you just have to combine things that have the same exponents attached to the same variables. So you have x squared, so the 9 and the 7 can be combined. So you're going to get 9 plus 7. I'm just going to write this out just for fun, but we know this in our head, right? It'll be 16. And then we have 9x on its own, doesn't have anything done. So we're going to get 16x squared plus 9x, which is D, okay? Ooh, you can breathe a sigh of relief. Not that bad, right, for the harder section. So you'll see even in the hard section, there are easy questions. There'll be some really hard questions, but we can do them all. If you have any questions on this, let me know. The basic principle, right, is like terms combined with like terms when you're adding. So you can't combine if they have different exponents, so that's why the 9x wasn't combined with the rest. Of 900,000 beads, 828,000 are silver. What percentage of the beads are silver? Okay, so this is just a percentage question. So it's part over whole, right? That's sort of how you find the percentage of something. So I will write that down. Part over whole. So here the part is 828,000. I actually wouldn't write these zeros out if I were doing it on my own, but I'm just doing it to show you. And I'll show you why I wouldn't write them out, because they're both nice thousands. So the thousands go away. Bye. All right. And then we have 828 over 900. And you don't even need to do the math there, because you can see 828 is going to be more than 72%, right? Because 720 of 1,000 would be 72%. And this is a bigger number on top, smaller number on the bottom. So it's bigger than that, bigger than that, bigger than that. And we get D, right? So we use the answer choice to help us be fast. We eliminate the zeros. Don't even need a calculator. But if you wanted to check on the calculator, go ahead. That's what we have Desmos for. And if you want to be fancy and do it in your head or on paper, right? Divide them both by 2. That's going to get you 414 over 450. And then you can divide both of those by 9, right? And that's going to give you 46 over 50, which if you don't already know is 92%. We can divide that. You can multiply it by 2 and get 92 over 100. Okay, so that's how this one works. Nice and straightforward. I really love percentage questions, but they can be challenging for people. If 2 parentheses 3t minus 10 plus t equals 40 plus 4t, what is the value of 3t? Okay, so first I notice that there is no answer choices. A lot of times I use the answer choices to give me some guidance, some idea. Are the answers in whole numbers? Do the answers have pi in them? And so on. But here, nothing like that. So I also noticed that it's the value of 3t, not just regular t. And when there's a random thing like, why is it 3t? Why not, if it's not going to be t, why not 2t? Why not 4t? Then you start working in your head, thinking, getting the juices flowing. Oh, maybe there's some sort of trick going on here. And we'll see if there's a trick. Okay. So I am going to subtract t here and get 2, right? So I'm going to subtract this t to move it over. It just feels right? So we're going to subtract that. We're going to get 2 parentheses 3t minus 10 equals 40 plus 3. Oh, I made my plus sign look like my weird t's. 40 plus 3t, right? I use that sort of like J shape to differentiate it between the plus sign and the t. So now I'm going to distribute here, and I'm going to get 6t minus 20, right? Always make sure to distribute to both parts. That's a Easy mistake people make. 6t minus 20 equals 40 plus 3t. And then I see, oh, maybe there's some 3t action going on here, right? Because when I subtract 3t, subtract 3t, then you're going to get 3t minus 20 equals 40. You add 20, right? Add 20 to isolate, and you're going to get 3t equals 60. And that's exactly what we're looking for. And we're done, right? 3t minus equals 60. We don't have to divide by 3. Here, if you did that and then you multiply by 3, that operation is pretty simple. It'll take you maybe 5 more seconds, 10 more seconds. But those are 5 or 10 more seconds that you can save for another question. And more importantly, you're learning the process of thinking about how it's 3t, right? And looking for a pattern that will get you to 3t. And here it saves you maybe 10 seconds, but on a different problem, it might save you 2 minutes or 3 minutes. Or it might make the problem possible when it seemed impossible before. So just keep that in mind whenever you see that they're asking for a weird, random value. There might be some sort of trick to it, okay? If at 5 parentheses x plus 4 equals 4x plus 4 plus 29, what is the value of x plus 4? Okay, the fun thing for me, which I did in another problem recently, right, is that it's not asking for x, it's asking for x plus 4. So that's like a hint. What are we looking for? If we look at the answer choices, right, we have 1 negative integer and 3 positive integers. So it's going to be a whole number, which is nice. It tells me that the math itself, the arithmetic, probably isn't that complicated. And now we see, oh, there's x plus 4 in the actual question, right? So I could distribute, move everything around, solve for x, and then add 4. And that would be totally fine. You can do that. I give you all permission to do that. But what I'm going to do is I'm going to move this whole unit, this 4x plus 4 unit, over to the left by subtracting by 4x plus 4. Or 4 parentheses x plus 4. Right, and I'm going to subtract that on both sides. So now this side's also going to get subtracted 4x plus 4. And we can treat that whole unit as something like 4y or something. So you imagine this was 5y and we're doing minus 4y. We get 1y, but instead of y, right, we have x plus 4. And then on the right, they go away. So we just got left with 29. And well, you see it, it is C, 29. And that saves us the danger, because if x plus 4 is 29, right, x is 25. That saves us from saying, oh, 25, and going with that, right? It also saves us a lot of time of distributing, subtracting, and working it out that way, because if we do it that way, it's just going to take much longer. So if you get it that way, that's totally fine, and I'm going to even show you how to do it that way, but I'm telling you this is what you want to do, okay? It'll save you time. So if you get that, you can move on. Bye. I'll see you next time. If you want to stick around and watch me work it out the long way, by all means. So 4x plus 4 plus 29, right? So we're going to distribute the 5 on the left. So we're going to get 5x plus 20 equals, we're going to distribute the 4x plus 16 plus 29. And that's going to give me 5x plus 20 equals 4x plus 45. And then I'm going to subtract by 20. Subtract by 20. And subtract. So I'm going to get 5x equals 4x plus 25. And now I'm going to subtract by 4x. Oops, going to run out of room here. Subtract by 4x, and then that's going to give me, I'm going to draw a little arrow. Oop. X equals 25, like we said, so then x plus 4 equals 29. And math's not that bad, right? But look at the first method. That was one step, basically, and I had it. And look at this method, right? Ugly. Ugly, ugly, ugly. So you can do it that way if we don't think of this x plus 4 method, but if you do think of it, that is really the best method. All right. A neighborhood consists of a 2-hectare park and a 35-hectare residential area. The total number of trees in the neighborhood is 3,934. The equation 2x plus 35y equals 3,934 represents this situation. Which of the following is the best interpretation of x in this context? And then if we look at the answer choices, right, there's no numbers, right? It's not about numbers here. It's about the concept in the equation. right? Because equations have baked in concepts when they're in word problems, and they want us to see if we can understand those. Okay, so we have the average number of trees per hectare in the park, the average number of trees per hectare in the residential area, the total number of trees in the park, and then the total number of trees in the residential area. Okay, so we're looking for X, right? And it's next to the 2, so it's associated with the park. So I would say it's not going to be something to do with the number of trees per hectare in the residential area. And it's also not going to be the total number of trees in the residential area. So we're going to eliminate those 2 answer choices, and we're left with A and C. The average number of trees per hectare in the park and the total number of trees per hectare in the park. So you've seen questions like this before, or equations like this before. I can make one up right here and you'll understand what I mean. Let's say we say there are t-shirts at a store and socks, and the socks cost $2 a sock, and the t-shirts cost $5 a sock. And I want to find out how many t-shirts and socks I can buy for $110. Okay? I know, you're like, why am I doing another problem in this problem? But you'll see why. Right? You could make an equation there, and let's say this is socks, and this is t-shirts. I'll call this T. So then we're going to have 2S plus 5T. I know my S's look like 5s, but you understand. Equals 110. Right? So it's the rate, the cost per sock, and the cost per t-shirt, and the number of t-shirts and the number of socks. So the tricky thing here is you would expect the 2 to be the trees per hectare, but the 2 is the hectare, the area, the total amount. So it's like this is the amount, and the X, it would be like the $2. So the X is going to be the trees per hectare, right? The rate, basically. So they flipped it on us, and that's what I think makes the question tricky. One thing I remembered when I was doing this, I was like, why would the residential area have more trees than the park? And then I was like, oh, this isn't the number of trees per hectare. It's the number of hectares in the whole, section, the park or the residential area. So then this would be the average number of trees per hectare in the park, right? So this is just something to watch out for in the future, right? They like to trick us by switching variables, but the equation is still correct, right? It still works out. You just find this, and it helps you to eliminate answer choices, right? And be like, the 2 is associated with the park, so I'm looking for something to do with the park. Okay, so for a certain rectangular region, the ratio of its length to its width is 35 to 10. If the width of the rectangular region increases by 7 units, how must the length change to maintain this ratio? And as we normally do, we'll look at the answer choices. It must decrease by 24.5. It must increase by 24.5. It must decrease by 7. It must increase by 7. Okay, so the ratio, right, of length to width is 35 to 10. Okay, great. So then we can make ratios. You can make into fractions. So we have 35 to 10. Right, that equals length to width. And then they tell us the width increases by 7. So let's do 7 is the W, right? So that's an increase of 7. How much does the length change to maintain this ratio? So we'll do this. So we don't have to worry about the middle part, right? That was just sort of setting up how the ratio is set up. And now we can just do 10 times L, so we're going to get 10L equals 7 times 35. Okay? And now from there, we're going to get 10L equals 245, right? And we're going to get L equals 24.5. So the math is pretty straightforward there. And honestly, you don't even need to do this math. I did it just for, I like to cross my T's and dot my I's. But if you look at the answer choices, you can eliminate multiple things right off the bat. Decreasing by 7, it's not going to decrease if you're increasing by 7, right? That would happen if you maybe misread the question. So then you're between increase by 24.5 and increase by 7. If it increased by 7, that'd be a 1-to-1 ratio. And maybe you don't know what this ratio is right off the bat, but you know for sure it's not 1-to-1. So then we would only be left with B, right? So you could do that question almost with no math, basically in your head. But I'm just writing it out to show you the concept that's like underlying the answer. So for this one, the way we do it is first we read the question. P equals 20 plus 16 over n. The given equation relates the numbers p and n, where n is not equal to 0 and p is greater than 20. Which equation correctly expresses n in terms of p? Okay. So n in terms of p, you want to isolate the variable, right? So when you isolate variables, you do the opposite of PEMDAS, which is going to be sad MEP, which doesn't sound as good, even though we have a word in there, right, with sad. But we're going to do the opposite first. So we're going to subtract 20. We're going to get p minus 20 equals 16 over n. Right now we have the variable we want isolated underneath the fraction, which can be annoying for some people, but you basically can flip both equations, or you can multiply by n and then isolate it. So I'm going to multiply by n and then isolate to show you the more classic way, right? So you're going to have n parentheses p minus 20, close parentheses, equals 16. And I'm not going to distribute, because if I distribute and then I have to factor it out, that's just a misstep. So I'm going to divide by p minus 20, right? Because it's getting multiplied by n. So to do the opposite, we just divide. And this is going to give us our answer, right? Which is going to be n equals 16 p minus 20, which is, when we look at this, D. Okay? So that's how we do it that way. If you want to do it by flipping, what you would do then is something like this. Look, you have p minus 20 equals 16n. Come on, come on. And you just flip both fractions, right? And you're going to get, you put all that underneath a fraction with a numerator of 1. So you're going to have 1 over p minus 20 equals n over 16. And then you just multiply both sides by 16, and you get the 16 p minus 20, right? So as long as you're flipping both sides of the equation, it'll work. You just want to be careful to make sure you flip the whole thing. And don't do 1 over p minus 1 over 20. You want to keep them all underneath the denominator. And that gets us D. Right? I love both ways. I think the first way is the more classic way that people have been taught. This feels kind of like a shortcut, but they're the same number of steps. So whatever floats your boat. The expression 24 over 6x plus 42 is equivalent to 4 over x plus b, where b is a constant and x is greater than 0. What is the value of b? So equivalent, right? It's just a fancy word for equal. So we can set them equal to each other. And then that's going to be 6x plus 42 equals 4 over x plus b. Okay, great. And then you can cross multiply. But first, you can simplify this side, right? So boom, boom, boom. Because 6 goes into everything here, so that becomes 4, that becomes just 1, and that becomes 7. Okay, and then we're going to notice something after this. We're going to cross multiply, which is like this, right? And cross multiply, which is like this. Maybe some of you already saw the pattern, but if you haven't, you'll see it in a second. So we're going to get 4x plus 4b equals 4x plus 28, right? Because we had x and 7 here times 4, so that's going to give us 4x plus 28. And then, so now we have this, the x's cancel, so we're going to be left with 4b equals 28. Why did the x's cancel, Sebastian? Because you subtract 4x from both sides to get them to go away, and they're equal, so then 4b equals 28. b equals 7. Okay, which is nice and clean. It's A, right? Okay, but you could do this all without even writing anything down, and I'm going to show you how. Whenever you have equations, I want you to be thinking, is there some sort of pattern? Is there some sort of trick, right? So here what I notice is, what's the relationship between 24 and 4? 24 is 4 times 6. What's the relationship between 6x and x? 6x is x times 6. Right? So the relationship between 42 and b, if they're going to be equal, is 42 equals 6b. You divide by 6 and b equals 7. You see how much easier that is, right? So that's really a great benefit of having good mental math skills and good number sense, that you can see what factors are what factors of something else, what numbers are multiples of something else, and you can combine that to make your life a lot easier, right? That version right there took me 10 seconds. The other version, not that bad, right? Still under a minute, but there's a higher chance of making a mistake there, and it's just more work, right? This way you can do it quickly, easily, and save your energy for the hard questions. So circle A in the xy plane has the equations x plus 5 squared plus y minus 5 squared equals 4. Circle B has the same center as circle A. The radius of circle B is 2 times the radius of circle A. The equation defining circle B in the xy plane is x plus 5 squared plus y minus 5 squared equals k, where k is a constant. What is the value of k? Okay, so if you know the equation for circles, then it's not too bad. If you don't know them, I'm going to show you right now. So the equation for a circle on a graph is, the standard is normally something like this. X minus h squared plus y minus k squared. Right, different k from the one they're giving us. These are just the letters they choose, and then we have r squared, right? So r, you could guess, is radius. So when we have this format laid out for us, like it is here, nice and clean, r equals radius. Okay? And then when we have this format nice and clean like this, h and k give us the center values of the circle. So h is the x value, and k is the y value. Okay? So if you know that, then this question is not too bad, because all it's asking for is k, right? And k is just going to be r squared. So the key part, right, is that we're looking for k, and that's in B, and it has 2 times the radius of circle A. So first we find the radius of circle A. So it has a radius of, it's r squared equals 4, so we'll say r A equals square root of 4 equals 2, right? Great. And then we're going to do RB. And again, this stuff you shouldn't have to write out. I'm just writing it out to show you my thinking, is 2 times 2, whoops, which is 4. And then k is going to be RB squared, right? So we'll do that here. K equals RB squared, and that's going to be 4 squared equals 16, and that's our answer there. Business owner plans to purchase the same model of chair for each of the 81 employees. The total budget to spend on these chairs is $14,000, which includes a 7% sales tax. Which of the following is closest to the maximum possible price per chair before sales tax the business owner could pay based on this budget? Okay, so you have $14,000 to spend total, and the business owner is doing it for 81 employees. So the most intuitive thing to do, right, is to do 14,000 divided by 81. Okay? And if you do that, you're going to get something like 172.83, or something. And you would round and say, oh, C. But that's not including the sales tax right now. Is the sales tax going to go on top of this and make the number bigger, or is it going to go below and make it smaller? Well, each chair has the sales tax, so instead of dividing simply by 81, what you should do is divide 81 times 1.07, right? Because it's 7% sales tax, so you're just doing that, and it's almost like you're doing it per chair, even though it looks like we're multiplying it with the employees. And when we do that, you can just use Desmos for that, and you'll get around 161.53. Okay, and that would be this one. So this is a simple rate problem, basically, or a proportion problem, where you have the total amount and you divide by like the rate or the total to find the value, right? So it's going to be 161.53. And the thing just to watch out for, right, is the 7% sales tax. And if you get that, then it'll be nice and clean. You'll use a calculator. This is definitely one, I usually don't use calculators that much, but this is one you want to use a calculator for. And You should know that because look at the answers. They're ugly answers. 148.15, 161.53, 172.84, 184.94. When I see that, I instantly know, oh, I should use a calculator because these numbers are not going to be clean. They're not numbers I can just do in my head. The graphs of the equations in the given systems of equations intersect at the point xy in the xy plane. What is the possible value of x? Okay, so it's kind of written weirdly here. The PDF made it like that. But this equation, 8x plus y equals negative 11, and 2x squared equals y plus 341. Now you can solve for y on each of them and then set them equal to each other and then solve for x, which is a great way, and I might do it after this, and you should stick around for that, but I'm going to do it with Desmos, and it's going to take me as long as it takes me to type and search, okay? So I'm going to bring Desmos over here, right? And then I'm going to type up the equations here. Let's see. So I'm going to type them up, and then once I have them typed up, I will move it up so you can see it in its full glory. And then 2x squared, right? And you just type it up the way they wrote it. It's totally fine as long as you are careful. I think on the test you can actually copy and paste a lot of times, so it's even easier. All right, so now we have this. We have the two equations, and let's see our answers. Okay, zooming out. So it has two places to meet, right? So it's going to be, okay, negative 15, 109, and 11, negative 99. Okay, so just looking here, a negative 15, negative 11, 2, 8. The answer is negative 15, right? Because it was a positive 11, but it was a negative 15. And it was asking for the x value, not the y value. And see, already we're done. Just like that. So now we will go back. We will circle that one. And we're done with this one in that way. I'm just going to show you how you would do it if you didn't want to do Desmos. I would really recommend Desmos, though. Another thing you could do, right, is set them equal to each other. So subtract 8x from this equation, from both sides. Ooh. Subtract 8x, and then subtract 341, subtract 341, right? And that would give us y equals negative 8x minus 11, and y equals 2x squared minus 341. Okay, and then you just set them equal to each other. So it's going to be 2x squared minus 341 equals negative 8x minus 11. Okay, and then you'll move the 8x over, you'll move the 11 over, and you'll get 2x squared plus 8x minus 330 equals 0. You can divide out the 2, so you're going to get x squared plus 4x. And we just care about the x's, right? We don't care about the y, so we can do it by dividing by 2. 165 equals 0. Okay. And then we're going to have x minus 11, right? Because we're going to have what multiplies to 165 and has a difference of 4, 11, and 15. But since it's a positive 4, we want the bigger number to be positive. So it's going to be x minus 11, x plus 15 equals 0, and x equals negative 15, comma 11, right? Because it's just you set each individual part equal to 0, and you still get the same answers, negative 11, or negative 15 and 11, right? And you didn't have to do this. Desmos was faster. But you know me, I love to do math. Any excuse I have to do a little bit more work on this, I will do it just because it's very satisfying to me. And I also prefer these types of things to Desmos, but even I, who don't love using the calculator, love using Desmos for this question because they made it so fast and quick. And all it's really testing is for you to understand how graphing works to show you the solutions. How many solutions does the equation 10 parentheses 15 x minus 9 equal negative 15 parentheses 6 minus 10x close parentheses have? Okay, so how many solutions? These are both. What I'm going to do is look at the answer choices, right? That's always one of my favorite things to do, is to look at the answer choices. And then when I have that, right, so we have exactly 1, exactly 2, infinitely many, and 0. Okay. And then if we look at these, right, they're linear equations because there's no variables, there's x on both sides. So you can almost think of it as a system of equations, even though it's just one equation. And when we have a systems of equation, right, what are our options? We can have, let's imagine it graphically, right? We can have, I'm not a very visual person, but with this I do like to do visuals, right? So we can have one line intersecting another line, and when I do that, right, there's one intersection. So it's possible to have exactly one, okay? And then we can have two lines that are parallel and never touch, right? That's when they have the same slope but different y-intercepts, and that would be 0. And then we can have one where they are the identical line, so it's one on top of the other, right? So let's say we had the original one, and then we just had the same exact line, maybe different, written in different form, and then just go right on top. That would be infinitely many. Here, though, we have exactly 2, and I don't think there's any way to get exactly 2. Well, I know there isn't, right? There's no way that two lines can intersect each other twice, so that's not going to happen. So even before you do math, you can eliminate this, and you're down to three choices. Okay, and then if we look at the equations, okay, they look different, but let's distribute. On the left side, you'll get 10 times 15 is going to be 150. X. 10 times negative 9 is negative 90. Okay. And then on the right side, we're going to get negative 15 times 6, negative 90. Okay. And then we're going to get negative 15 times negative 10, which would be positive 150x. So what do I see right before I do anything else, right? You always want to take a moment after a step to just quickly analyze. And you see, oh, they're the same thing on both sides. They're just written in different orders, but that doesn't affect anything because it's just addition and subtraction, right? So that means they are the same equation. If they're the same equation, it's going to be C, infinitely many. Okay. Now, I showed you graphically why that works, right? Let's see what happens when I try to combine everything. So let's add 90, and you'll see why this happens. If you already understand it, then good, you can move on. But if you don't, you can see exactly the mathematical reason why it's infinitely many. So that's going to give us 150x equals 150x. And you can stop here maybe and think, well, no matter what x is, the two sides will be equal. Or you can subtract 150x from both sides, like that, right? And you're going to get, oh, let's see, we're going to get 0 equals 0. So no matter what, they're equal to each other, right? X has gone away. In an equation that was 0, right, where there was parallel lines, what would happen would be, let's say this had been like 88, and you added 90, right, you would be left with like 2 equals 0. Okay? So when the quadratic function f is graphed in the xy plane, where y equals f of x, its vertex is negative 3, 6. One of the x-intercepts of the graph is negative 7, 4, 0. What is the other x-intercept of the graph? Okay, great. I love this question. Let's see. So it's going to be this and this. We have no equation though, right? So what are we going to do? Okay, I want to visualize this. I'm going to visualize this here. Maybe I'll use Desmos later to show it more visually, but let's just imagine you have this, right? You have negative 3, 6. And then you have negative 17 over 4, which is like negative 4.25. And then you're going to have something else, right? So remember, the x value at the vertex creates what is called the line of symmetry. Why is it called that? Because like a mirror, it makes a mirror image on both sides, and it's symmetrical on both sides, okay? So our line of symmetry is going to be x equals negative 3. Okay. For me, this question, it took me a long time to really understand the concept behind it. But once you get it down, you can do this question and all the other ones that are like this. So negative 3. So what's going to happen is however far you are from the vertex on this solution, that's the same distance you're going to be on this solution. So you could think of -3 as the midpoint between the two solutions, okay? So -3 is midpoint of solution. So I'm going to write that. Midpoint of solutions equals -3. Okay, so then what's the equation for midpoint again? Anyone? Yeah, it's hard for me to think about it off the top of my head too, but when I start writing it down, it comes back to me. So I'm going to start writing it down, right? So we're going to have the average of the two values, right? So midpoint is mid equals x1 plus x2 over 2, right? So here this equals -3. Okay, so we're going to do x1 plus, let's say x2 was that -17 over 4. You could also do -4.25 if you want. I'm a big fan of fractions, and I hope you are too, because they are beautiful things. But if you're not and you want to do decimals, do it that way. So we're going to have 2 on the bottom. We're going to have -3. Great. So now we're going to multiply both sides, everything by 2. I'm just going to put everything in parentheses and put a 2. Okay. That's going to give us x equals x1 equals, oh no, we still have the plus, right? So x1 plus -17 over 4 equals -6. Then we're just going to add the -17, so we're going to add 17 over 4 and add 17 over 4. So that's going to be, boop. One of these days I'm going to figure out something else to do besides these arrows. But for now, we're going to stick it like this. X equals -6. So that's going to become -24 over 4, right? Because we like to have common denominators when we're adding. Plus 17 over 4. And that is going to get us, anyone? -7 over 4. If you look at the answers, right, everything was over 4. I should have done that earlier, that's my bad. But we're going to eliminate these, and we're going to get -7 over 4b. Okay, nice and clean. A would have been if you had thought of the x solution as the midpoint. That could happen if you had, instead of adding 17 over 4, you subtracted 17 over 4. But we didn't do that. You didn't do that. I didn't do that. We nailed it down. Question 14. All right. We have a graph this time. That could be intimidating for some. Some people love them. But let's check this out. The graph of y equals f of x plus 14 is shown which equation defines function f. And then we have -1/4x minus 12, -1/4x plus 16, -1/4x plus 2, and -1/4x minus 14. All right, so there's a trend here, right? It's all -1/4x. These are all linear equations. You look at the graph right there, it is going down by 1/4, so we don't care about the slope. What we care about is the motion, right? The y-intercept. So what they're telling us is what we see now is f of x plus 14, right? F of x plus 14. And what we want to do is find f of x. So that would be, let's call this g of x. And we could say f of x equals y minus 14, right? Okay, so remember with transformations, what do we have, right? Let's just focus on shifts because that's what we're doing here, right? This horizontal shift where we shift left and right, and that's when you add or subtract to x value. Okay, and then we have vertical shift, which I like more because it's not complicated like the horizontal shift can be. And that is when you add or subtract to function. So that's what's happening here, right? We're not doing f of x parentheses plus 14. I'll show you what I mean in a second. So horizontal, right, would be something like y equals f of x minus 5 or something, right? That's a horizontal shift, and that'd be a shift to the right 5. Horizontal goes in the reverse that we would think. Vertical goes where we want. You add 5, you go up 5. You subtract 5, you go down 5. So here we take the function that we see, right? The y equals the y equation here, and we're going to subtract 14 to find the actual equation for the f of x. So what's the y-intercept of this one? It is plus 2, so we're going to do, let's see, okay. So the equation here is y equals negative a quarter x, which we don't even have to really calculate because we see every answer choice has that anyway. They gave that to us. So we're going to have y equals negative 1 quarter x plus 2. And then f is going to be negative 1 quarter x plus 2 minus 14. So that equals, what does that get us? Negative 1 quarter x minus 12. And if we look at our answer choices, right, not B, not C, not D, it is A. All right. 64x squared plus bx plus 25 equals 0. In the given equation, b is a constant. For which of the following values of b will the equation have more than one real solution? Okay, so how do we find when it'll have more than one real solution, right? That's the question. So when will this equation have more than one real solution? So think about it graphically first, right? This is a parabola because it's an x squared equation. When you have that, you can have either it going above, and that would have no real solutions, it going below, also no real solutions, it going up but crossing twice, 2 real solutions, it going down, crossing twice, 2 real solutions, or it just being tangential and touching just once, 1 real solution. Okay? And you can have that going down as well, right? So it's saying it has to have more than one real solution, and that it will, how are we going to do that, right? So the way I'm going to think about it is think about the quadratic equation. Okay, so we have negative b plus or minus square root of b squared minus 4ac all over 2a, right? And the way you know how many solutions you have is by something called the discriminant, which is just the inside part of the quadratic, of the square root. Okay, so when we have that, what you can do then is you can find it based off of that. So if that part equals positive, then the square root would be real, and we'd have a plus and minus version, so we'd have 2 solutions. If b squared, so I'll write that here, right? So b squared minus 4ac is greater than 0, 2 solutions. B squared minus 4 equals 0, right? The square root of 0 is just 0, plus or minus of 0 is the same thing. So if that happens, we're going to have 1 solution. And if b squared minus 4ac equals, or is not equal, but is less than 0, 0 real solutions, right? So that's the equation version, right? So this right here would be, let's say we had a little graph, crosses twice. This right here, we have a little graph, crosses exactly once. And this right here, we have a little graph, never crosses, okay? So that's what we're talking about. And what we want, right, is to have more than one real solution. So that just means 2 solutions, right? That's the only options for this. So how are we going to get that? All right, so let's do, remember here, we have 64 as the A value. And we have B as the B value and 25 as the C value. Okay, so with that, we can go from there. So we're going to plug in what we know and then solve for b squared, right? So we need the 2 solution value. So for that, it's going to be just like this. So b squared minus 4ac, b squared minus 4ac is greater than 0. Okay, and now we plug in. B squared stays b squared minus 4 times 64 times 25 has to be greater than 0. 4 times 25 is 100. 100 times 64 is 6400. So b squared minus 6400 is greater than 0. So b squared, not greater than 0, sorry. We add 6400 to each side. B squared has to be greater than 6400. So it could be anything where when we square it, we would get something greater than that. So we're going to square root both sides. Square root both sides. And that's going to give us, when we go right here, b is greater than plus or minus, well, there's 2 options, right? B can be greater than plus 80, and b can be less than negative 80. Because the square root, right, will work that way. So if we look at our answer choices, not b, not c, and not d, it is a, right? 91 squared would be, a little bit above 8100, around 8200 something. So that would work, and that's our answer. So now you can see how to do this do this conceptually, right, with the math, so you understand why it works and how it works. But if you were confused, you could also just do Desmos, right, and plug in each answer choice and see where they cross twice. So, all right, so with this, right, let's say you plug in 40 for D, right, you see how it never crosses the x-axis, right? It's going to give us a negative discriminant, so that would work that way. If we plug in 5, same thing, right? If you plug in negative 80 for B, right, it's going to cross exactly once. We could zoom in and see. Right, the vertex is right there. So that's crossing once because it's 0. And then if we plug in negative 91. So you can see there, right, when we graph, we get what we want. But it's helpful to see how it works in the equation to understand it, because they'll make it more abstract. They can do it more abstractly, and then you would not be able to use Desmos. But Desmos, if you can use it here, that'll be really fast, right? So I hope that helped for today. Again, it's pretty quick either way as long as you know the rule about the discriminant. And if you don't know the rule about the discriminant, you can use Desmos, just sort of plug in, guess and check almost, right? The graph of 7x plus 2y equals negative 31. And the xy plane has an x-intercept at a, 0 and a y-intercept at 0, b. Where a and b are constants, what is the value of b? Okay, so this one is not too bad. It just maybe isn't something you haven't done too much. And you have to remember b over a. So you have to find both values, right? So what you can do, right, x-intercept a, so plug in a for x and plug in 0 for y, right, because of a, 0, and then we're going to plug in 0 for x and b for y afterward to solve for that. So when we plug in a for x, we get 7a plus 2 times 0, right, because this is the x-intercept and they give us the point for it, which is nice, equals negative 31. And that's going to give us 7a equals negative 31. And a equals negative 31 over 7. Okay, that's nice. And then let's do b. Same thing, except now it's going to be 7 comma, or parentheses 0 plus 2b equals negative 31. 2b equals negative 31. And b equals negative 31 over 2. So now we have b over a, right? So we're going to do b divided by a right here. And when I have letters or things that are fractions over each other, what I like to do is think of them as division, because it clears up any issues with, like, well, what's being divided and what's being multiplied. So that's going to be negative 31 over 2 divided by negative 31 over 7, which becomes negative 31 over 2 times 7 over negative 31, right? Keep, change, flip. That's something I've heard teachers use. So then the negative 31s cancel, and you're going to get 7 over 2, right? So you get 7 over 2 as your final answer. I'll move my head for you to see. There it is. And then this right here, right, is going to give us D as our answer. And if you look, right, there was always the 7 and 2, 2 and 7. It was just about remembering to cancel out the negatives and then the 31s canceling, right? So that's how this one works, right? You could think about it. If you were really like on top of your game, you could see 7x and 2y and think, okay, well, the 7 is going to become the A part, and then the 2 is going to become the B part, but they're going to be reversed. So it's really going to be 7 over 2 at the end. And that would work, but I'm not that quick on this one, okay? So if you're quick like that, great, but you don't need to be quick like that. You can just work it out like this and just remember the negative 31s cancel, and it becomes, a very nice equation, right? They consider this a hard question, and I think, it's not easy, but I think you can all get this down. In the given system of equations, t is a constant. If the system has no solution, what is the value of t? Okay, great. So 4x minus 6y equals 10y plus 2, and ty equals 1/2 plus 2x. Okay, so what it's telling us, right, is that it has no solution. So let's think about that graphically, right? If it's no solution, then what we're talking about really is we have some coordinate plane, right? We have one line, and then the other line is parallel and they never cross, right? So what does that mean for us in terms of the equation? So I'm going to rewrite the equations here. 4x minus 6y equals 10y plus 2, and then I have ty, I make my t's look like j's to keep them separate from the plus signs, equals 1/2 plus 2x. Okay, so what that means is they have the same slope. How do we get the same slope, right? That is when the two equations have the value on the x, right, the coefficient on the x and the coefficient on the y are proportional. So they're not the same equation. If they have the same equation, they'd have infinite points crossing, but they have the same slope. So what I'm going to do is I'm going to move the x over and see what that gets us. So we're going to have 4x minus 6y. Well, actually, for this one, right, I'm going to move the 10y over. So I'm going to subtract 10y. So minus 10y minus 10y. So it's going to be 4x minus 16y equals 2. And then I'm going to subtract the 2x, and I'm going to get negative 2x plus ty equals 1/2. And I don't actually care about the 2.5. All that matters really is that they're not going to be the same value when I multiply this, right? They don't have the same proportions. Because if they had the same proportions as the other parts, then it would be equal to each other and they would be the same line. So what do I mean by proportions? Well, the proportion is how you multiply from one coefficient to get the other one. So we're going from 4 to negative 2. So that's going to be multiplying by negative 1/2. Okay? So why does that matter? Because if we multiply this by the same value to get t, then we'll have the same ratio between the negative 2 and the t. So that's going to be negative 16 times negative 1/2, which will give me positive 8. So t equals 8. Now, why does that work? Because if we look at the first one, right, and we look at the slopes, it's going to be negative of this, because we move it over, it becomes negative 4x, divided by negative 16. So the slope on the first one, right, is going to be, here, I'm going to put it here, slope equals negative 4 over negative 16, which equals 1/4. And now on the other one, we're going to have negative 2 over 8, which also equals 1/4. Okay, so one way you could do this, right, is just to move things over from the beginning, find the slope of the first equation, and then solve for t to find the slope of the second equation, making it equal, right? But I just like to work on proportions, set them on the same side. So I'm dividing by -1/2 to get from 4 to -2. So I'm going to divide by -16 by, or not dividing by -1/2, multiplying by -1/2, right? So I'm going to multiply -16 by -1/2, okay? And if you want to do it the slope way, the way you do that is you just find the slope of the first one and set the other one equal to that with t in it. So it's going to be like this, look. Okay, so I already did the slope there, but I'm going to redo it for anyone who has questions on that. If you understand this question, bye, sayonara. I'll see you all next time. But if you want to stick around for fun or to understand it better, then you'll see. So on the first one, right, we have 4x minus 16y equals 2. So I'm going to subtract 4x to find the slope. Subtract 4x. And I'm going to get -16y equals 2 minus 4x. And then divide by -16y equals 2 plus 4/16 x, which is just 1/4, right? So that becomes 1/4. And then I can set that equal to the other one, right? So it's going to be 1/4 equals 1/2 equals 2/t. All right, if I look at this, right, to find the slope, I'm just going to divide by t, and then that makes t equal to 8, right? So it's the same thing. I like the proportion method where I'm just sort of thinking of how the equations relate to each other, but if you focus on the slope like this, and that makes more sense to you, do it that way. An isosceles right triangle has a hypotenuse of length 858 inches. What is the perimeter in inches of this triangle? Okay, so hypotenuse right of a right triangle, right, is the side across from the right angle. And this is going to be a right angle. We're going to have isosceles means two sides are equal. So this is a special right triangle, right, where we have x, x, and x√2. Like this, right? And it's asking for the perimeter, so we have to add them all together. But first we need to find what x is. So the hypotenuse is 58. And this is a 45, 45, 90, right? Because that makes an isosceles right triangle. So 58 equals x√2. There was a question like this on the October test. I think a little more challenging than this, but I'll put a link up here for you to see that. So x√2 equals 58. So we're going to divide by √2 to get x by itself. And that's going to be x equals 58 over √2. Okay? And we don't like to have roots on the bottom usually, so we're going to multiply by √2 on top, √2 on the bottom. It's just a notation thing. It makes it more workable. So that's going to be 58 √2 over 2, which equals 29 √2. Okay, so that is x. Now we have x. I'm going to switch it up to red to do some work there. And I'm also going to erase a bit. Okay, so, well, I'm going to erase after. Also, I saw a really good movie tonight, Wild Robot. I would recommend it if you have a chance to see it in theaters. They're not paying me to say this. It's really just generally very good. And if you can't see it in theaters, definitely worth seeing it at home too. You know, we all got to have our breaks from work and studying. So let's see. Okay. So we have that. The perimeter, right, is going to be, I'm going to write it here. Perimeter equals x plus x√2. So it's going to be 2x plus x√2. And x is 29, right? This is x. Let's see where it went. All right, so then we're going to do that. Now I'll do some erasing. Okay. I'll erase here. Okay. And now up here, let's do this, right? So 2 okay, 2 29 root 2 plus 29 root 2 times root 2 is going to be 58 root 2 plus 29 times root 2 times root 2 is going to be 29 times 2, which equals 58. So we have 58 plus 58 root 2. And that is, any takers? Not A, right? A does not work for us here. Okay, good. Not B. It has to be C, 58 plus 58 root 2. Okay, so we're going to do C. Okay, so this one we just have to find what x is. There's other ways to do it. You could think of 58 as x and then do just x divided by root 2, but I usually think of the legs as the x's. And I'm sure people have other brilliant ways to do this one. For the linear function f, the table shows 3 values of x and their corresponding values of f of x. Function f is defined by f of x equals ax plus b, where a and b are constants. What is the value of a minus b? Okay, so it tells us it's a linear function, which is great. And also, it says it here, right? Because it's ax plus b, there's no square roots or squares or exponents, right? So what we're going to do is we're going to do a is the slope, right? Because it's being multiplied by the x. And b is the y-intercept. Because it's on its own, it's being added or subtracted from it, right? To find the slope, remember the equation is y2 minus y1 over x2 minus x1. Looking at our answer choices, we see, right, that everything is a whole number, or technically an integer, right? And that just lets us know we're not dealing with fractions, so the math shouldn't be too bad. Hopefully we don't need a calculator. And then slope is going to be, on the bottom we'll do 2 minus 1. On top we'll do 0 minus negative 64. And that's going to get me 64 over 1. So the slope is going to be 64. You'll need to use the equation on this one because you could look and just be like, okay, we're going up 1 on x, up 64 on f of x. And that's nice and clean, right? So it's just 64 over 1. You hopefully wouldn't have to write it out. If you do, that's totally fine. But I wouldn't worry about that too much. Okay, so then let's see. We need to find the y-intercept. To find the y-intercept, we're going to do a point from the equation, right? So we're going to say, let's take the point 1 and negative 64. So it's going to be y equals 64x plus b, right? And then we're going to plug in 1 for x and negative 64 for y. So negative 64 equals 64 parentheses 1 plus b. Then we're going to subtract negative 64, right? Because 64, we're going to subtract that 64. We're going to get b equals negative 128. Right, so then we have negative 128. So then to find a minus b, we're going to do 64 minus negative 128, right? So this is a new part. And that equals 192, which is D, right? So I think the biggest mistake people make is they do 64 minus 128 and get A, but we're not going to do that, right? You see double negatives become positive. We're going to get positive 128. So 64 plus 128, and that is D. Dataset A consists of 10 positive integers less than 60. The list shown gives 9 of the integers from dataset A. 43, 45, 44, 43, 38, 39, 40, 46, 40. The mean of these integers is 42. If the mean of dataset A is an integer that is greater than 42, what is the value of the largest integer from dataset A? Okay, so we know that all the integers are less than 60. Right now the max is 46, so you have to be between 46 and 59, right? And we're missing a number, we'll call that x. Then how do we find this, right? We know the average, the mean, is an integer of these numbers is 42, right? So then what you can do when you know the mean of these integers is 42 and there's 9 of them, you can just find the total by doing 9 times 42. And that's going to get you 378. The mean of data set A is an integer that's greater than 42. So let's say it's 43. And then there's 10 integers. That's going to give us 430, right? As a total. So if it's 430 and we're at 378, then the missing number would be 430 minus 378, which is 52. And that works, right? Because we're looking for a number that's less than 60. So x could be 52. So what is the value of the largest integer? It could be 52. Now let's see. What if we had a ratio, or not a ratio, mean that was 44, right? We would do 44 times 10, which equals 440. And that is going to be 440, minus 378, right? Because those 9 numbers didn't do anything. And that's going to be 62. And that does not work because that's above 60, right? So that means x equals 52. And that means our largest value is 52, okay? So, pretty straightforward. I think one thing that helps is knowing the mean is 42 and knowing you can find the total by multiplying that by the number of numbers. If you didn't know that, you would add all these numbers together and you would still get 378, but that would just be more work and there's a higher chance of messing up. I mean, you could use the calculator and again, that wouldn't be too bad. Just, typo or something could throw you off. So it's nice to see that they give us that and then work from there. And then you just find this. You have to keep in mind that there has to be less than 60. And it makes sense, right, that if we're going from 430 to 440, that the 10 jump is going to be too big. So we're left with x equals 52. For groups of 25 or more people, the museum charges $21 per person for the first 25 people and $14 for each additional person. Which function f gives the total charge in dollars for a tour group with n people where n is greater than or equal to 25? And if we look at these equations, right, we have linear equations. We have slopes and we have y-intercepts, right? So I'm going to start by thinking about how at 25 people, how much should I be charging, right? And then I'm going to eliminate. So it's going to be 25 times 21, and that's going to be 525, right? You can use a calculator. The way I do it is I think of groups of 4, right? Because every group of 4 25s is 100, and there's 5 of those. So that's 500 plus an extra one, so 525. So when you have 25 people, you should be able to do 525 when you plug in for that, right? So this one looks like that, right? Because that's almost like the starting point, but remember, we're not starting at 0 here. We're doing n is 25, so it's going to be, I would eliminate c because that's 35n is just makes no sense as a slope, right? We're not adding $35 at any point per person. So we're going to do, let's do b just to see why it doesn't work, right? If we do that one, 14 times 25 plus 525, we're going to get, this is going to be 350 plus 525, and that's going to give us 875. That's too much, right? We want it to be 525, so it's not going to be B. Now let's do A, right? We plug in there 14 times 25 plus 525 equals 14, oh no, not plus 525, sorry, plus 175 equals, this is going to be 350 plus 175, that gets us the 525. So it should be that one, D wouldn't work, right? That's going to be 350 plus 21, which is not it. And then you can think about this, right? If you had 26 people, we would add $14 because it would be 14 times 26, which is just one more. So that'd be 364 plus 175, and that would be 539, which makes sense, right? So that's going to give us A as our answer. And that is it for this one. So it's not too bad. You just want to be careful of keeping track of things and not think 525 just because that's what you get after 25 people, because then you're double counting for this first 25 people. And you just want to be careful not to do that, right? It's a smooth process from there. And then it's just the 175. So in triangles LMN and RST, angles L and R each half measures 60 degrees. LN equals 10 and RT equals 30. Which additional piece of information is sufficient to prove the triangle LMN is similar to triangle RST? Okay, so we're talking about similarity, right? Not congruence. And when they're similar, right, they look the same. I'm going to draw this and butcher it, but you got my point, right? So we have one like this, and then we have one, maybe it's bigger, maybe it's smaller, but the angles are the same, okay? So then we're going to do, and I really recommend drawing out for this one. This will be L. This will be N. This will be not R. It will be N. Okay, now I'm going to introduce you to R, S, T. So it tells us L and R are each 60. 60, 60. So we need to find these angles and make sure they're the same as these angles, right? And then LN equals 10 and RT equals 30. Okay, so if they are similar, this triangle is 3 times as big as this one, right? So if they told us MN equals 7 and ST equals 7, that would prove they're not similar because it's not following the same ratio. So we're going to cross that out. Goodbye to you, N. Or goodbye to you, A. Okay. Bye-bye. Nice knowing you. MN equals 7 and ST equals 21. Okay, that's interesting. Then we can maybe do some talking, right? Because this is this, and this is this, but we don't know anything about the angles, and we don't know if they are proportional. So again, not enough information. Not as obviously wrong as A, but wrong enough to not be what we want, right? We are strict about how to prove it. The measures of angles M and S are 70 and 60 respectively. Okay, so that would prove what? Ooh, proves us not similar. Because then angle M is 70, angle S is 60, and that does not work at all, because then they're totally not congruent. Because this 60 and 60, right, not going to work. And I know they're corresponding because they give us to them in LMN, RST, right? That order should be corresponding. And L and R are each 60, so that's not going to work. All right, last one. M is 70 again. Okay. And T, interesting, is 50. They aren't corresponding, but what does that tell us about the other angles? This is 60, this is 70. They have to add up to 180. So plus N equals 180. Some good math is going to give me 130 plus N, right? Because 6 plus 7 is 13, and you just add the 0. And then N equals 50. Ooh, I'm liking that. I am liking that. Yes, I am. Because look, the T is also 50. And then what would this angle be, right? It should be 70, but let's just check. 60 plus 50 plus S equals 180. And then it's going to be 110 plus S equals 180. S equals 70. Yes, yes. That is working for us, right? So now that proves that they're all equal. The angles are all equal, so that means the triangles are similar. So our answer is D, all right? All right, that's what I have for you today. Hope you didn't miss my intros and conclusions too much. If you did, go back and watch the solo videos, and if you have questions on these, let me know. I'm currently doing reading and writing, module 1 from Bluebook Test 1 as solo videos, and there'll be compilations coming, so if you have questions on that, also let me know. I also have Bluebook Test 4 Math Module 1 also finished, and Bluebook Test 4 Math Module 2B is coming soon, all right? And I hope the sun is shining on you, and if it's raining, I hope it's cleaning your windows and watering your plants. Bye.